That mechanism you've just seen is simultaneously the most satisfying and frustrating thing I've made. So in this video, I'm going to take you through the design, the manufacturing process, and show how it all comes together in the end to make a piano that holds my keys. Now, in my previous video, I created an early prototype of this mechanism, and in the comment section of that video, a couple of people identified the same issue, which is that you need two hands to operate it, one to push down and the other to retrieve your key, and that is just a little bit too inconvenient. Fortunately, the comment section also proposed a solution, so thank you very much to the person who said add a latch, because that will mean you can operate it with one hand. Seems like a brilliant idea and should be fairly straightforward to implement, right? The obvious place to start here is a pen, and although a pen uses a rotary latching mechanism, I did actually find a linear version that I modelled up in Fusion 360. Here you have two arms that basically move up and down, and if I activate the cross section, you can see that they guide a pin along a very special channel. This all works great in the magical world of CAD, but it was hopelessly fiddly and quite unreliable when I 3D printed it. So having tried the sensible approach of using an established method, I then gave myself permission to create something completely new from the ground up, which, as it happens, is a long and annoying process. Everything was so small and fiddly. I mean, just look at these tiny rods and springs. I was also battling the accuracy of my 3D printer, which just wasn't consistent enough for these small components. But there were occasional glimpses of success, and each time I learned, iterating again and again, until this happened. Great news, I've just assembled the latest version of the mechanism, and this one actually works. Look at it, you ready? Click down, locked, and release. So good. It's proper satisfying as well. You can see I've got little latches going, springs are doing their job, the bits inside. I should probably show you how it works actually, so let's do that next. Editing Robin here. We're not going to do that next. What we're going to do is move straight on to the build of the video, and what I'll do is put the description of how the mechanism works right at the end for the people who love it. I mean, I love that kind of stuff, but I appreciate it's not everyone's cup of tea. So if you do like that, it's waiting for you. For everyone else, don't you worry, let's crack on with the build. All right, so it's Sunday morning in the workshop. I've got my machine running, and that's making the components for the mechanisms, as you can see here. I've done about 2 or 3, I think this is the third one, and then I'm obviously going to need 7 in total, so that's running away in the background. Meanwhile, I'm turning my attention to this piece of cherry, so that is going to be the base of our key holder, and to do that I've got to program up the cam. So this is the simulation that I'm currently running, which looks good, but only time will tell when we actually put it on the machine, which is the next job. Right, so the glue is just drying on the cherry. I have my lovely log here to weigh it down, and we're using the tape and glue method. It's mounted on some MDF, and that's about to go onto the machine. So I've got my 1/4" end mill, you see here, and that's going to be doing the majority of the work. And I also have exported my program and popped it into the USB stick hole down here. So everything is ready to go. Let's get machining some cherry. As the machine was running automatically, I would then assemble the mechanisms alongside by hand, beginning each time by laying out that full kit of dowels and standoffs and bolts that I would need to build each one. Then came the intricate process of sawing, hammering and bolting that brought the whole thing to life. As the result of a productive weekend, I finally had my full set of 7 working latches, which I excitedly fitted into the cherry base. Next, I shifted my attention to making the white piano notes out of a lovely piece of maple. The machining was pretty straightforward to begin with. I surfaced off the top and then roughed out a slot down the middle. Now after this, it did get exciting because I used a T-slot bit to machine an undercut on the inside of the maple key. Now I've never done anything like this before, so I was really eager to see if it would work. You'll see that it's a bit too loose, actually. It's very loose. It should be nowhere near that kind of fit, because I suspect what I've got wrong is this slot is just too big. I thought resolving this issue would be a simple fix, but what can I say? It was way more tedious than I expected. Okay, so solving that toolpath issue was way more tedious than I expected. However, I've done it. So a couple of prototypes later, and I have the note on my piano with a properly spaced slot down the middle. And to show it to you, I'm going to introduce it to the mechanism, and do enjoy this moment with me because it has taken a little bit of getting to. So here we go, slot you into place, just like that. And it's got a really nice push fit to it. It's not too tight, but it's also not too loose, and it goes on so nicely. Hits up against a little stopper that you can see there, so it's always going to be the right depth, and you're like this. I even noticed in the CAD model before we started that there was going to be a collision between this bolt and the cap, so what I've done is just put in a little clearance hole there. So it's all come together, just need to make another 6 now, so let's crack on with that. I went over to the router table and added a cheeky chamfer onto the bass and the white notes. I felt much better after this, as it changed the design from seeming quite chunky and blocky into something much more refined. I've just finished machining the bottom of the cherry bass, and I've got these lovely little brass feet which are going to fit into these 2 recesses you see here. So let's see if the hole's the right size. Number 1. Oh, that is snug. That is nice. Number 2. Oh, it's gone well. I'm pleased with that. For the lid of the piano, I took this opportunity to engrave the name of my channel, Inventive Robin, using a 45-degree V-bit. And this does seem like a natural point to say that if you are enjoying the video so far, please do consider subscribing for my future content, and also give this video a like so it can reach more people like you. All right, bit of a progress update, because I've just started to assemble together all the pieces I've made so far, and look at it, it's really starting to actually look like a piano. We've got the mechanisms, we've got the bass, we've got the keycaps, all fitting together. And it's just so nice to hold it in my hands, because this has been in my head in CAD models for so long. And look, now it's in front of us. Proper clicking mechanisms. Ah, brilliant. So let's, before we get ahead of ourselves, let's assemble the last key. Pop that on. That goes into there. And then I've got this sort of top piece, you see, which has got some dowels. So we use quite a lot of dowels on this project because they do the job nicely. That fits in there. And look at it. That is, don't tell me that's not satisfying. That is properly satisfying, and it's not even done yet. So next steps are going to be to use these 3D printed guides, 1, 2, because they're going to tell me where the holes go on the front. Just going to have to do them by hand. I did consider doing them with the CNC, but it was going to be a whole janky mess, so we'll not do that. I'll drill them out, cut them by hand, and then we bring in the lovely brass. So this is going to be what I make my hooks out of. They're going to be poking out the front of there, and you can really start to see it come together now. So on the home straight, getting excited, but just a little bit more to do. The key question for the brass was how to hold it securely and accurately in the machine. So I chose to make a sacrificial fixture by cutting a tight slot in some MDF. As the toolpath progressed, it removed material both from the brass and the MDF, so I was kind of gambling that the surviving sections would still fit tight enough to prevent any movement. On the whole, it worked really well, and that was a good thing because I only had enough material for one attempt. For the black keys, I had 2 lovely blocks of walnut, and things seemed to be going to plan. Until I found out that I'd actually designed them wrong, and then in trying to rectify that situation, I only made things worse. I got some more walnut and I had a second attempt, and to be honest, I'm not massively happy with the results, but I decided, you know what, it's good enough, let's just move forward. Alright, exciting moment because all the components are now complete and I've laid them out in a kit on the table, which just means that the last thing to do is to assemble them all together, which is the moment we've all been waiting for really, so let's get stuck in. I started on the back of the casing, screwing in the wall hanger and gluing in the brass feet. For fixing the mechanisms, I 3D printed these little clamps that have a push-fit nut inside of them. They then dock into some little cutouts on the side of the mechanism and is all secured using bolts screwed from the underside of the casing. I then proceeded to slide the white notes on, which you can do thanks to a little bit of play and wiggle room within the joints of each mechanism. The black keys just slide on using some dowel pins, and as I pushed them into place, it started to look like a proper piano for the very first time. The last piece of the puzzle was that cherry lid, which slid on using some dowel pins, and it did need a fair bit of encouragement into its final position, so let's just hope it's never going to need to come off again. After months of design and several weeks of machining, I finally had the finished piano in front of me. And overall, I was delighted. I mean, sure, if you look closely, it's not quite perfect. 1 or 2 of the mechanisms are slightly quirky, let's say. However, I'd give this a solid 8.5 out of 10. And with another design iteration, I'm pretty sure we could get that up. The final home of this project will be in my hallway where it can fulfill its intended purpose of hooking my keys, right? So without further ado, let's go and hang it on the wall. As I was filming, my 2-year-old daughter stopped by to give her own narrative of the project, which I think you're going to enjoy.
Pop. Keys off. And
And here's my mechanism. So I've actually just removed the side plates in CAD so you can see it a bit clearer. Those who saw my last video will be familiar with the idea of pushing down on the note and having the hook come out the front. But the bit I really want to draw your attention to is these 3 components at the back. So we've got our lock, which rotates backwards and forwards, our latch arm, which lifts up like this, and our blue pin, which rotates inside the traveling bar, which slides along the bottom. So here's the full cycle. Step 1 is we push down on the key, and that's going to require the latch arm just to lift up a tiny bit until we get right to the front of the travel. Now, there's actually a spring, it's not modelled in CAD, between here and here, and that spring is going to pull this down until it hits the bar, and that covers off the exit of that blue pin. The same spring actually pulls this lock forwards. The spring does quite a bit, and it's responsible for 2 moving parts, and that is then the full forward position of the key, as you see. So the next thing is then to release it, and this is where it gets very interesting. So as this comes up, look at this little blue pin. It gets stuck in this dent and actually forces it up. So you end up with this kind of mutually escalating behavior where one pushes the other until they get locked right into this position here. And that is the locking position basically where it can't move backwards any further. You ask why it can't move backwards any further? It's because there's a pin here which collides with a slot on the outside of the mechanism and stops that piece from going any higher. Now, an important part is that this can then swing into place, again using that spring, and as we then push down in the release push on the note, another spring, again not modelled but you will see it in the real version, pulls this blue section down, and that can then slide gracefully underneath the mechanism here, which is now locked in a fundamentally different position. And then to reset, it then nudges back on this lock until it goes back far enough just to release the little beak of our latch arm, and we're back to where we started. And that's the project complete. I mean, this one has been a lot of work, I'm not gonna lie, but oh, the reward is so worth it. I'm proper chuffed with this. So my next step is to go and get all the keys from around my house and hang them up, pride of place, on the piano. And that just leaves me to say thank you very much for watching, and I'll catch you in the next video. Goodbye.